Dear friends, welcome to Bond with RK Chemistry YouTube channel. In coming videos, I am going to explain the previous year questions from 2010 to 2019 of HCU Entrance PG examination in chemistry. Today, I am going to explain the previous questions which are appeared in HCU Entrance. The topic is thermodynamics. In 2019, there are 7 questions from thermodynamics. 2018, 2 questions. 2017, 3 questions. 2016, 2 questions. 2015, you have 3 questions. 14, 6 questions. 13, 2 questions. 2012, 4 questions. 2011, 5 questions. And 2010, 4 questions. This lesson is very important for HCU PG entrance examination. You are getting at least minimum 2 questions from thermodynamics. Let's take the questions. The internal energy of a system is a function of, here V is volume, T is temperature, P is pressure and S is entropy. Here internal energy du is equal to TdS minus PdV and dH is equal to TdS plus VdP and dA is equal to minus SdT minus PdV and dZ is equal to minus SdT plus VdP. So these are the 4 relations. This is the relation of internal energy, enthalpy, Helmholtz free energy and Gibbs free energy. Okay, let us take internal energy. This is the function of S and V. So U is a function of S comma V and enthalpy is a function of S comma P, entropy and pressure, and Helmholtz free energy, that is A, it's a function of T comma V, temperature and volume, and G is a function of T comma P, temperature and pressure. So internal energy, what is the option? Internal energy is a function of S and V. So B is the correct option. Enthalpy change for the transition of solid tin from the gray form, the density is given, to the white form at 10 bar and 298 Kelvin is plus 2.1 kilojoule mole inverse. The internal energy change for the transition in kilojoule mole inverse. Okay, what is the relation between enthalpy change and internal energy change? We know the relation delta H is equal to delta U, change in enthalpy is equal to change in internal energy plus delta Ng RT. Here delta Ng means this is the difference in number of gaseous molecules in reactant side, product side minus reactant side. This is the delta Ng, number of gaseous molecules on product side minus number of gaseous molecules on reactant side. Suppose if you take this in this conversion, okay, tin, okay, solid form, this is the solid, and this one is converted into gray form. This is the gray form, solid, and the tin again you are converting into solid, white. So here there is no involving of gaseous molecules. On reactant side you have solid, on product side you have solid, on reactant side you have solid. So delta Ng is equal to 0. Then when delta Ng is equal to 0, delta H is equal to delta U, since delta Ng is equal to 0. The number of gaseous molecules on product side and reactant side 0, so delta Ng is 0. So delta H is equal to delta U. Here delta H is given, so the delta U will be plus 2.1 kilojoule per mole. The equation that is not true for mixing of two ideal gases at constant temperature and pressure is. We know that for ideal gases, there is no interaction between gaseous molecules. So when you mix two ideal gases, there is no change in internal energy. So delta U mix is 0 and delta H mix is also 0, and there is no release or absorption of heat. So delta Q mix, change in heat or transfer of heat, there is no transfer of heat. Q mix is equal to 0. But when you mix two gaseous molecules, it's a spontaneous process. Delta S mix always greater than 0. So when you mix two ideal gases, delta U mix, delta H mix and Q mix 0, but delta S mix is greater than 0 and delta G mix less than 0. So these are the two relations. So which one is not true? B is not true. So B is the correct option. 2 mole of helium, 3 mole of neon and 1 mole of argon are mixed at 300 Kelvin. Assuming that these gases behave ideally, the Gibbs free energy change of mixing is nearly equal to. We know that delta S mix is equal to minus NR sigma xi ln xi. So this is a delta S mix equation. Then delta G mix, what is the equation? Delta G mix, actually this one is equal to delta H mix minus T delta S mix. Here delta H mix is 0. Since it's a ideal gas, delta H mix is 0. So delta G mix will be equal to minus T delta S mix. So it will be equal to nRT sigma xi ln xi. Here n total number of gaseous molecules, total number of moles of gaseous molecules, and xi mole fraction of a particular gas. And here what is the total number of gaseous molecules here? Here you have helium and neon and argon. Here how many moles are there? 2 moles, 3 moles and 1 mole. Finally, how many total number of moles are there? It's a 6 moles. So n is equal to 6, and mole fraction of helium, the number of moles of helium by total number of moles of helium, neon, argon 6, and this one is 3 by 6 and this one is 1 by 6. So this is the mole fraction. This is the number of moles and this is the mole fraction. So you will get 1 by 3, 1 by 2 and 1 by 6. These are the mole fractions. When you substitute delta G mix is equal to, so delta G mix is equal to nRT 6 into, what is the R value you have to take? This is in kilojoules. You have to take 8.314 joules. And what is the temperature? 300 Kelvin, and sigma xi ln xi. For helium, 1/3, 1 by 3 ln 1 by 3 plus, and neon 1 by 2 ln 1 by 2 plus 1 by 6 ln 1 by 6. So if you take natural log 1 by 3, 1 by 2, 1 by 6, and if you calculate, you will get around minus 15.12 kilojoules. So this is the answer, minus 15.12. Actually you will get in joules, you have to convert joules into kilojoules by dividing with 1000. Here this many joules, you have to divide with 1000 after completion of this calculation. Okay, what is the answer? Minus 15.12. Just you have to use a scientific calculator for this calculation. The isobaric thermal expansion coefficient of an ideal gas, T is equal to temperature, V is equal to volume, is. Here you have coefficients, thermal coefficients and pressure coefficient, alpha, beta and gamma. Alpha is equal to, okay, this one is isobaric thermal expansion coefficient, isobaric 1 by V, dou V by dou T at constant pressure. And beta is equal to minus 1 by V, dou V by dou P at constant temperature. And this one is equal to gamma, it's a pressure coefficient. These are thermal coefficient, and here there is a pressure coefficient 1 by P, dou P by dou T at constant volume. Okay, this one is a pressure coefficient. Here, isobaric thermal expansion coefficient. What is isobaric thermal expansion coefficient? This is isobaric at constant pressure. It's a thermal expansion. With respect to temperature, there is a change in volume. So this alpha is isobaric thermal expansion coefficient. So for ideal gas, what is the value? You have to find out dou V by dou T at constant pressure. So we know that for ideal gas, PV is equal to RT for 1 mole of gas, V is equal to RT by P, then dou V by dou T, when you differentiate with temperature at constant pressure, so you will get R by P. Here the dou T by this one, R by T, dou by dou T at constant pressure. So at constant pressure, this one R is constant, P is constant, so it will be R by P, dou T by dou T. So this one is 1, so you will get R by P. So alpha is equal to 1 by V. What is this value? Dou V by dou T at constant P, you are getting R by P. So again PV is RT. There is a cancellation of R. So finally you will get 1 by T. What is the answer? Correct answer? 1 by T is the correct answer. Which of the following is not an extensive property? In thermodynamics we have intensive properties, intensive and extensive property. Okay, extensive property depends on size, mass and volume, and it's a additive property. But intensive property, it does not depend on size, mass, volume. It's not an additive property. Suppose if you take density, it does not depend on size, mass or volume of the matter. It is independent. So if you take mass, it's an extensive property. Volume is extensive property. Heat capacity is also extensive property. It's directly proportional to mass of the matter. And specific heat capacity, okay, you are specified the amount, you are fixed the amount. Specific heat capacity means heat capacity of 1 gram of substance or 1 kilogram of substance. So when there is a term specific or molar or molal, okay, if you take molar quantities or molal quantities or specific quantities, the quantity will become intensive. Suppose if you take molar mass, molar volume, molar heat capacity, all will be intensive. Suppose when you take mass, volume and heat capacity, these will be extensive. So which one is the correct option? Which of the following is not an extensive property? Specific heat is not an extensive property, it's an intensive property. It is independent of amount of substance or matter. So D is the correct option. The entropy change in the isothermal reversible expansion of 1 mole of a perfect gas from 7.6 to 2.9 atmosphere at 300 Kelvin is. What is the entropy change? Delta S is equal to Nr ln V2 by V1. It can be written as minus Nr ln P2 by P1, or it can be written as ln P1 by P2. Here this is the P1 initial pressure, this is the final pressure P2, and the number of moles of gas N is equal to 1. So you have to substitute these values 1 into R. It is in Kelvin inverse. You have to write R value in calories 1.98 into ln P1 by P2. It's 7.6 by 2.9. So it will be equal to 1.98 into around, you will get 0.96. So when you multiply this one, you will get around 1.907. What is the correct option? C is the correct option. The change in the internal energy of a gas is equal to heat supplied. The correct statement among the following is, this one is the first law of thermodynamics. This question is based on first law of thermodynamics. We know that according to first law of thermodynamics, the change in internal energy is equal to heat transferred and work done, Q plus W. For sign convention, what is the sign convention? Heat is supplied. Heat is supplied to the system. So here Q is plus Q and internal energy is equal to heat supplied. Delta U is equal to heat supplied, means W is equal to 0. In this case, W is equal to 0. When the change in internal energy of a gas equal to heat supplied, when W is equal to 0, then delta U is equal to Q. Then the gas is expanded isothermally. Okay, when there is expansion of gas isothermally, delta U is equal to 0. But here delta U not is equal to 0, delta U is equal to Q. So this one is not correct. The process is carried out at constant volume. Suppose we know that W is equal to minus P external into delta V. When the process takes place at constant volume, delta V is equal to 0, then W is equal to 0. When W is equal to 0, delta U is equal to heat supplied. So this one is correct. The gas is expanded under constant pressure. Okay, when there is expansion of gas under constant pressure, W naught is equal to 0. So delta U is equal to Q plus W. So this statement is not correct. The process is carried out irreversibly. In this case, W may or may not be 0. So this one also incorrect. So which one is the correct? The process is carried out at constant volume. B is the correct one. Dou E by dou V at constant temperature for an ideal gas is, what is the dou U by dou V at constant temperature? It is the internal pressure. This one measures the internal pressure of a system. For ideal gas, we know that there is no interaction between gaseous molecules, so there is no pressure. No interaction, so that's why there is no pressure. So the internal pressure, that is dou E by dou V at constant temperature for ideal gas is 0. For real gas, if you take real gas, there is interaction between gaseous molecules. The dou E by dou V internal pressure is equal to dou U by dou V at constant temperature. This one is greater than 0. it's a positive. For real gas, it's a 0. For ideal gas, it's a 0. For real gas, it's a positive. Argon gas is expanded reversibly and adiabatically from a volume of 50 liter to 200 liter. If the initial temperature is 300 Kelvin, then the final temperature would be. It's an adiabatic process, reversible process, and adiabatic process. In adiabatic process, what is the relation between temperature and volume? This is the volume and this is the temperature. What is the relation? TV power gamma minus 1 constant. This is the relation in adiabatic process. Adiabatic. So T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. You can write T2 by T1 is equal to V1 by V2 power gamma minus 1. Here temperature is given T1 and the volume V1 and V2. You have to find out T2. What is the T2? So T2 is equal to T1 into V1 by V2 power gamma minus 1. For monoatomic gases, argon is monoatomic gas. Argon, what is the gas? Argon, it's a monoatomic gas. For monoatomic gas, gamma is equal to, it's a ratio between Cp by Cv, it's equal to 5 by 3. 5 by 3. So T2 is equal to T1. What is the temperature? 300 V1 by V2. What is the V1? 200. Okay, 50 by 200 power gamma minus 1, 5 by 3 minus 1. So T2 is equal to 300. It's a 1 by 4 and 5 by 3 minus 1, it will be equal to 5 minus 3 by 3. So it will be 2 by 3. So it can be, when you simplify this equation, when you calculate this equation by using calculator, you will get around 119 Kelvin. The equation connecting molar heat capacity at constant pressure to molar heat capacity at constant volume for an ideal gas is. What is the relation between heat capacity at constant pressure, that is Cp, molar heat capacity at constant volume, that is Cv. What is the relation? Cp minus Cv is equal to R. This is the relation between Cp and Cv. So you can write Cp is equal to R plus Cv. Okay, this one is very important equation. Heat of neutralization between HCl and NaOH is 13.7 kilocalorie mole inverse, and between HCN and NaOH is 3 kilocalorie mole inverse. The heat of ionization of HCN in kilocalorie mole inverse is. Okay, what is neutralization between heat of neutralization between HCl and NaOH? It's a strong acid and it's a strong base. For ionization, there is no need of energy. So in this case, there is a release of H plus from HCl and OH minus from NaOH, and there is a neutralization H2O. Here what is the Q value? Q neutralization is equal to minus 13.7 kilocalorie mole inverse. But in case of weak acid and strong base, first there is ionization of weak acid. HCN, this one dissociates into H plus and Cn minus. Here let us take the heat involved in this step. Let us take Q is equal to X. Let us take. And what is the second step? The second step is H plus OH minus, H plus from HCN, OH minus from NaOH. There is a neutralization H2. So the second step, Q neutralization is equal to minus 13.7. Okay, these are the two steps which are involved in the neutralization of HCN with sodium hydroxide. Here the final value is given. For these two steps, what is the Q value? Okay, the Q, let us take Q dash is equal to 3 kilocalorie per mole. 3 is given. So the Q dash is equal to Q plus Q neutralization. So these are the two steps which are involved in the neutralization of HCN with NaOH. So what is the Q dash value? 3, and Q you have to find out, and this one is minus 13.7. So finally, what is the X value? X is equal to, here you have to take Q is equal to minus 3. Always heat of neutralization is negative. So this one also minus 3. So finally X is equal to minus 3 plus 13.7. So you will get 10.7. Okay, B is the correct option. Given the Q is the heat transfer to a system, okay, heat transfer to a system. Let us take this is a system, heat transfer to the system Q, and W is the work done on the system. W is the work done on the system, and delta U is the change in internal energy of the system. Which of the following is correct? Heat transfer to the system, so plus Q. When heat is transferred to the system, plus Q, and work done on the system, plus W. So delta U, change in internal energy, is equal to Q plus Q plus W. For an isothermal processor, if you take isothermal processor, in isothermal process, delta U is equal to 0. Here, isothermal process, for ideal gas, delta U is equal to 0. When delta U is equal to 0, Q is equal to minus W. For an isochoric process, W is equal to 0. When W is equal to 0, delta U is equal to plus Q. So this one is incorrect, this one also incorrect. For an adiabatic process Q is equal to 0, so delta U is equal to plus W. Okay, this one also incorrect. For a cyclic process, delta U is equal to 0. So when delta U is equal to 0, then is equal to Q plus W. So Q is equal to minus W. So this one is the correct option. D is the correct option. Given the enthalpy changes, okay, these are enthalpy changes, and that standard states for iodine and chlorine are I2 solid for iodine, chlorine gas for chlorine at 298 Kelvin. The standard heat of formation of ICl gas at 298 Kelvin is, what is the standard heat of formation? Standard heat of formation means formation of ICl from its elements at standard condition. So these are the elements at standard condition: I2 solid and Cl2 gas, and there is a formation of ICl gas at 298 Kelvin. You have to form 1 mole of ICl, so you have to take 1 by 2 and 1 by 2. Okay, this is the equation which represents the standard heat of formation. Let us take here some Q. Let us take Q1. The heat is Q1. You have to find out what is the Q1 value. Here you can write I2 solid. I2 solid can be converted into I2 gas. I2 gas. Here you have to take half mole of I2 solid. It is converted into half mole of gas. What is the energy which is involved? 15.0. So it will be 15.0 by 2. So you are dividing with 1 by 2. And the next one Cl2. Next one Cl2 gas. Or you can take I2. 1 by 2 I2 gas. And this one is I gas. Okay, what is the energy? 36.1. So simply you divide with 2. And what is the next one? Cl2 gas. Let us take 1 by 2 Cl2 gas and Cl gas. What is the energy which is involved? 57.9 by 2. Suppose if you add these three equations, you will get 1 by 2 I2 plus 1 by 2 I2 solid plus 1 by 2 Cl2 gas, and finally you will get I. Here there is a cancellation of I2 gas, 1 by 2 I2 gas and 1 by 2 I2 gas. So finally you will get 1 by 2 I2 solid plus 1 by 2 Cl2 gas is equal to I gas plus Cl gas. So when you add I gas plus Cl gas, ICl gas, okay, this is the equation. I gas plus Cl gas gives rise to ICl gas, so reverse equation. So you have to take negative minus 50.5. Suppose if you add all these equations 1, 2, 3, 4, you will get this equation. Let us take this one as 1, 2, 3 and 4. If you add 1, 2, 3, 4, you will get the fifth equation. So what is a Q1? Simply Q1 is equal to, simply add the energy terms, 15 by 2 plus 36.1 by 2 plus 57.9 by 2 minus 50.5. So when you add these terms, you will get plus 4.0 kilocalorie per mole. This is the correct option. Which of the following is the condition for delta H naught is equal to T delta S naught of a chemical equilibrium? Okay. When there is a chemical equilibrium, we know that delta G naught is equal to 0 at chemical equilibrium. So delta G naught is equal to 0 means we know that delta G naught is equal to delta H naught minus T delta S naught. So delta H naught is equal to T delta S naught at chemical equilibrium. When delta G is equal to 0, delta Cp is equal to 0, delta Cp is equal to delta Cv is equal to 0, or K equilibrium is equal to 0, or K equilibrium is equal to 1. We know the relation between K equilibrium and delta G naught. Delta G naught is equal to minus NR T ln K equilibrium. Suppose K equilibrium is equal to 1. We know that ln K equilibrium is equal to 0. So this one delta G naught is equal to 0 when K equilibrium is equal to 1. So this one is the correct option. For which set of delta H naught and delta S naught will the reaction be spontaneous only at high temperature? High temperature. So this is a relation, delta G naught is equal to delta H naught minus T delta S naught. Suppose if you take delta H naught, delta S naught, what are the possible values? Negative, positive, negative, negative, or positive, positive, or positive, negative. These are the possible values. Suppose delta H naught and delta S naught, both delta H naught is negative and delta S naught is positive. The delta G naught, when delta G naught is less than 0, spontaneous. This is the condition for spontaneity. Always delta G naught less than 0 at any temperature, at any T. At any T for this condition. So suppose delta H naught less than 0, negative, and delta S naught negative. In this case, at low T, delta G naught is negative. Suppose the delta H naught positive and the delta S naught positive, and the delta G naught is negative when at high T, high temperature. So for delta H naught positive and delta S naught negative, for this at any temperature, delta G not greater than 0. At any temperature it is not spontaneous. So what is the correct option? Only at high temperature spontaneous. When it is possible, only at high temperature, entropy should be positive and delta H naught should be positive. So here in which case both are positive, this is the correct one.